I think we had a great day of content yesterday. I think today we're going to pick up on some familiar themes that were discussed yesterday, and one is really focused on decentralization. And as Brian told our story yesterday of how we became interested in the space, for me, it was, once I got past kind of the mental model of just thinking of digital assets as currencies and more about the various use cases for decentralizing anything where there's a functional intermediary really resonated with me. And I think a lot of that had to do with some of the thinking that our first speaker, Olaf, has done, and talking to him and listening to of some of the work and the speeches that he's given. So today's format this morning, briefly, Olaf will give about a 45-minute keynote. We'll do some Q&A, and then we're going to do two panels that Laura Shin will be moderating. One is on infrastructure, so discussing all of the groups that are kind of developing an on-ramp for the digital asset space. And then we'll have a number of institutional investors discuss their perspectives on performing investor and operational due diligence in the digital asset space. So with that, I'll turn it over to Olaf.
Okay, thank you, everyone. So I'm really excited today to talk to you about the future of blockchain technology. So most of you probably at this point have heard a lot about Bitcoin and a lot about this concept more broadly of cryptocurrency. So one of the myths I'm here to dispel today is the idea that this technology is very limited to this idea of currency or the peer-to-peer cash use case, and really talk about a much larger suite of ways that I think this technology will be used in the future. So when we're talking about decentralization and what types of veritable middlemen can be removed by using this technology, I think that it's actually a much larger swath of actors than most people generally imagine. So a lot of what I'm going to be talking about today is a bit forward-looking. The idea is not for you to fully understand or totally comprehend all of these concepts, but rather to take away something that you can go learn a bit more about later. Because it's way too hard to learn all of this in 1 hour. It's taken me about 7 years. So first, there's this very basic question, which is, what is cryptocurrency? And so I think a lot of people in their mind have this idea that Bitcoin and cryptocurrencies compete with these, right? They're similar to fiat currencies or gold and silver, and that the very different cryptocurrencies are maybe just different versions of e-gold or something like that. And so again, I'm here to tell you that you should take this concept and just throw it in the trash. It's a very limited way to actually view what this technology is capable of. Viewing this as a currency is a convenient metaphor, but it's ultimately an incorrect metaphor for thinking about what this technology is really capable of. So there's a few specific features of cryptocurrency that make it very, very different from these fiat currencies you see on the screen. And I want to go over one by one, but what I view as really the very critical differentiators of cryptocurrency. So first, cryptocurrency is run 100% on computers and is defined algorithmically by the code that is run on these computers. So this is actually a screenshot of me downloading the Ethereum blockchain. So each of these blocks of text is actually a block in the Ethereum blockchain coming through, filled with transactions and executable contracts and all sorts of things like that. This looks very different than, say, the US Federal Reserve or other monetary policy groups around the world that are defining what monetary systems look like. In cryptocurrency systems, this is 100% codified and programmatic, right? So there's just a very, very different feature on the onset, which is that the monetary policy, so to speak, of these systems, the rules of the system, is defined by code rather than by any sort of group of actors. A second feature, and this is also a very, very critical one, is that these technologies are all fully open source. So this screenshot is actually just a picture of the Bitcoin repository on GitHub. GitHub is a website where software developers can actually store and interact with various pieces of open source code. So like this is actually just the Bitcoin code, file by file. You can go read line by line the entire Bitcoin code base and theoretically understand very, very precisely how Bitcoin works. The fact that this is open source means that hundreds of thousands of developers from all around the world, regardless of their age or background or anything like that, can interact with the Bitcoin core code, and they can actually copy that code, they can amend it, they can alter it in any way that they see fit. So what this means is you have this open source environment of rapid experimentation. Open source technologies move very, very quickly, historically speaking. The internet itself is a totally open source kind of system. What this means is that the pace of development is not limited to any one group, any one corporation, or anything like that. It's really a very meritocratic system where anyone in the world, if they have a good idea, can contribute to the core Bitcoin protocol. They can also copy the core Bitcoin protocol and create their own protocol. And so these things branch off and are kind of forked and patched very, very quickly in this global open source environment. So this is a very, very different development cycle than you might see at a large company like, say, Microsoft or IBM. And the fact that this technology is fully open source means that there is a sort of iterability or remixability to it that just does not exist with traditional closed web platforms. If I have a new great idea for how to change Facebook, I can't exactly just submit a code pull request to the Facebook GitHub repository. It doesn't work like that. I can't see the Facebook code. I couldn't contribute an idea if I wanted to. And I'd probably be breaking all sorts of laws, and I just wouldn't have access to any of those systems. In Bitcoin, anyone in the world with an idea like that can contribute. A third core one is transparency. So the core way that these cryptocurrency networks and blockchain networks function is that each individual node in the network actually verifies every transaction that occurs in the network. So every piece of computation that occurs at that network level, on my actual device, it's verified. And by these thousands of nodes all around the world, all verifying these transactions and computations, you actually get extremely high security guarantees around the actions that occur in that secure blockchain environment. Sometimes we actually refer to this as the blockchain itself as a very secure execution environment, where you can actually execute things like peer-to-peer cash transactions, or what we will get into, which is much, much more complicated types of transactions, all within that very, very secure blockchain environment. So this transparency is critical. And what you see on the screen here is each of the nodes are Bitcoin addresses, and every line between a node is a transaction of Bitcoin. So you can actually verify the full history of the entire ledger, this ledger being the blockchain that's a kind of tamper-proof ledger of every transaction or computation that's ever happened in that system. So this transparency, the fact that this is open source, and fully programmatic, algorithmic through code are all extremely critical components of how the system works. And again, things that make this very, very different than the way, say, the US dollar works. A final characteristic, and one that we'll be getting into a bit more, is the fact that this is fully programmatic. So what you see on the screen is actually a bit of a detailed information about what a Bitcoin transaction looks like. So there's this cryptographic hash, which is basically an alphanumeric thing that looks like a very long password. This contains transaction data. You can see what's called an input script and an output script there. These are all components of how a Bitcoin transaction works. And the important thing here is that this system works with computers, right? So this is a kind of language, in a sense, that computers can speak very, very easily. So the fact that this, now we have programmatic money, opens up what the global community of software developers can accomplish with this technology. Instead of being limited to new types of financial instruments, say, or new types of transactions, based on legal frameworks or a consortium team of say, banks or financial institutions. It's really just limited to what is possible with software. And when you think about what is possible with the software iteration, it's really limitless because code is ultimately just a way to execute ideas or human thought in a very logical and precise manner. So by having money be able to be iterated on in this kind of programmatic, computer-friendly manner means that there is no real logical limit to what is possible to be created by this global community of open source developers. And we'll be coming back to how a little bit more advanced programmability can lead to all sorts of types of behaviors that go far beyond just peer-to-peer cash or payments. So I want to take you through a little visual history of cryptocurrency through the lens of mining. Mining here being the use of hardware in order to generate what are called hashes. These are basically like guessing very, very difficult passwords using computers. And through the process of mining, these miners are actually finding blocks and building the blockchain. So in the Bitcoin system, blocks are found about every 10 minutes. And those blocks are then added to the blockchain. So really what miners have are computers. So this is what mining was like in 2011. And this is the year that I got into Bitcoin and wrote my undergraduate thesis on this technology. My professors gave me a bit of a hard time when I made that decision. And a lot of the reason that they gave me a bit of a hard time can be encompassed in this photograph. So this is really what the kind of cryptocurrency technology and community looked like at that time. You can see someone is kind of like on their DVD case, maybe mining some Bitcoins on the side, right? This isn't exactly their full-time job, right? And this is very much a hobbyist project. This is an online open source community that's kind of coming together to build this quirky new technology. Over time, though, Bitcoin became a little bit more popular, and the demand for Bitcoin increased, and so the price of Bitcoin went up a bit, which then increases the kind of financial rewards that miners have, and thus increases the investment that miners put into their hardware setups. So in 2013, mining kind of heated up a bit. The entire cryptocurrency space kind of grew by an order of magnitude. And this is kind of what it looked like then. So you can see, we're still in this guy's house, right? Like we're in his living room. It's filled with all of this special hardware. I'm not sure if he's living here anymore, but we're not yet at really industrial scale. We're not exactly venture backed here, right? So to me, 2013 was very much an era of transition from very obscure open source hobbyist project. To be clear, I think that the global user base of cryptocurrency in 2011 was probably around 100,000 people, right? This is a very, very niche thing. In 2013, Coinbase, my former employer, hit over 1 million users, and that was one website, right? So we're talking about a substantial growth over those couple years. In 2015, through 2013, 14, 15, this is really when substantial professionalization happened. You can see venture backing likely entered the space, and mining became very much industrial scale. So here you see it occurring in a data center, and this reflects a lot of the changes that were happening in the whole cryptocurrency industry. Just a sense of building more sophisticated infrastructure and preparing for a more substantial long-term future. And we're very, very far at this point from this kind of obscure open source hobbyist project occurring in the kind of living rooms across the world. And when you look at mining facilities today, this is a real picture of a mining facility in China. These are very, very substantial infrastructure installments. The revenues of these largest mining facilities are in the single-digit billions of dollars annually. And as you can see, we're really far away from the guy's DVD case in his living room in a relatively short period of time. So through these images and kind of the lens of mining hardware, I just want you to get a sense very viscerally of the type of growth that this technology has seen since its inception. This whole technology space and area is less than 10 years old, and it has grown extremely rapidly. This is an exponential rate of growth, and it's because of a lot of these properties that I talked about at the beginning, where you get a sort of perfect storm of iteration and expansion of what is possible here, between the open source nature, totally programmatic nature, and the fact that this is really just a global group of software developers all working together to improve this technology in any way that they can think of. So next, I kind of want to go over a little bit of what's happening beyond Bitcoin. I think a lot of you have heard about Bitcoin. My firm is called Polychain, right? So a lot of what we're thinking about are blockchains outside of Bitcoin, and really technologically what those blockchains enable. So one of the big myths I want to dispel to you today is that these various cryptocurrencies are not the same technology copy-pasted a few times. So this is not like gold and silver and copper. It's very, very different from that. It's sort of like gold and a television or something like that. Just very, very different sets of technologies here. So Bitcoin has a very simple scripting language. This is basically a programming language that developers can use to interact with that underlying protocol. And it has two what are called opcodes, op equal verify and op check sig. This kind of run the entire network and verify every peer-to-peer cash transaction that occurs in the network. This equal verify is basically do inputs equal outputs. So when I hand you a $20 bill, was it really a $20 bill, or did I take a $1 bill out of my wallet and tell you it was a $20 bill? So you're kind of checking that, and then check signature. So if I hand you $20, did it come from my wallet or somebody else's wallet? And this is a cryptographic signature. Only I will be able to transfer you that money if it came from my wallet. So these are very, very simple in a sense, right? And these kind of two opcodes really run the entire Bitcoin network. So what some very smart developers around the world started thinking about is, what if we could run more complex operations in this secure blockchain environment, right? So have these operations, again, verified by these large industrial scale miners, by nodes all around the world, but have much more complicated behaviors than these very simple verification of transactions from A to B. And so as developers started thinking about how they could improve or change Bitcoin, what you've seen is just an absolute tidal wave of alternative open source blockchain technologies. So this is a real picture of, I really must emphasize, a tiny slice of the various cryptocurrencies that have been created over the course of many years since Bitcoin was created. Again, because this technology is fully open source, there's absolute permissionless global innovation. So any open source developer in the world, they can be 11 years old, it doesn't matter where they're located, they can view the open source Bitcoin code, they can amend it in any way they'd like, they can improve the technology in a small way or a large way, and deploy a new blockchain from their living room. What this means, it's a little bit chaotic. You've probably sensed that if you've tracked this space a little bit. But what it means is that there's just there really is an avalanche of new technologies being created all the time, because there's no limit on what anyone can create. No single entity or actor is a sort of gatekeeper for what can be created in this ecosystem. So what you've seen is a huge number of improvements on various things in the core Bitcoin technology. Keep in mind, Bitcoin was mostly designed in 2008. We've made substantial improvements in many of the underlying systems that Bitcoin relies on. Things like the underlying cryptographic signatures that Bitcoin relies on, some of the networking stack, and notably this scripting language, or in newer systems, what's often referred to as a virtual machine. And in Ethereum, the second largest cryptocurrency by market capitalization, you'll hear them talk about the Ethereum virtual machine. This is basically a mechanism to execute these more complex operations in this secure blockchain environment. So rather than just doing cash transactions from A to B, you can do substantially more complicated operations and have those same security guarantees that you get because of these industrial scale miners and distributed network that are all verifying those types of computations. So thinking about all of these various cryptocurrencies, how do you select which ones to actually invest in? And this comes to the Polychain Thesis, which is based around a concept we call, and many in this cryptocurrency space, call Web 3.0. The basic idea here is that instead of Web 2.0 companies, and these are the major web platforms that you see today. So these are things like Facebook, Etsy, eBay, Uber, Airbnb, anything where there's a massive network of users, where most of the value for an individual user actually comes from the other users, not from the platform itself, right? You go on Facebook not because of Facebook per se, but because of all your friends that are on Facebook. Very similar, if eBay didn't have any sellers, eBay wouldn't be a very useful platform for the buyers, right? So these kind of marketplaces that depend on these very large-scale network effects, where the platform, though, is actually owned by a single gatekeeper and single entity. So again, coming back to this idea of Facebook, Facebook is an owned platform by one entity that can allow what types of behavior occur on that platform. It is very much not like blockchains, where there's this open, permissionless, open source global innovation. Instead, it's very much a closed source system with a central entity that acts as, in a sense, a point of weakness to me. These cryptocurrency systems are extremely anti-fragile, meaning that they're very hard to disrupt or shut down in any capacity. These major centralized web platforms, as we've seen with recent controversy surrounding Facebook, have a lot of substantial problems, especially as so much of the entire world's kind of activity and relevant action all moves onto the internet. So to me, a very critical component of this idea of Web 3 is how we can decentralize the web and move away from these massive platforms on the internet, like, say, the Facebooks and eBays and Ubers of the internet, and towards a more decentralized web. And there's lots of benefits when you start to think about this decentralized web. Outside of just this permissionless innovation, you don't have a single gatekeeper. And so in the United States, we often enjoy a good set of freedoms. The entire world isn't necessarily like that. And by decentralizing the web, you can actually get a much safer protection of rights globally. So when we're thinking about how to actually build this decentralized web stack, there's a lot of core underlying technologies required in order to enable these kind of end user applications to emerge on the high layer of this web stack. So a lot of what Polychain is investing in today are these very low-level technologies that will enable slim slices of this stack of technologies that will kind of encompass the entire Web 3 experience, right? So to give you a very simple example, consider, say, a decentralized Twitter, right? If you want to build a decentralized Twitter, you are caught with a very simple problem, which is, where do you store the tweets? Like, literally, what server do the tweets live on? And so you realize very quickly, if you're trying to build a decentralized version of Twitter, where there isn't one central platform, but works rather more like email, where email isn't Email Inc. or Email LLC, but rather a decentralized protocol that many different people or clients can interface with. When you're starting to build that decentralized Twitter, you're caught with this question of decentralized server storage. And so then you really need to fix this problem of how do we build a decentralized server system before you can build an application like a decentralized Twitter. So when I talk about this stack of technologies, it's a stack of dependencies, really. Before you can get to that end user application, you really need to build these lower level decentralized systems. And that's kind of the era we're in today when thinking about blockchain technologies. We're still a couple years away from any sort of meaningful penetration of end user applications. And by the time, though, we start seeing very significant use of the end user applications, a lot of the investment opportunity in these very core underlying technologies will likely have passed. So to me, it's sort of like investing in the pipes of the internet in, say, somewhere in the era of 90 to 95, rather than investing in individual websites. So to me, if this Web 3 thesis turns out to be correct, I do think that these will be some of the most valuable systems the world has ever seen. I do think that we will see trillion-dollar protocols proliferate en masse before we really see trillion-dollar companies. Just to give you a sense of how big I really do think this is. So I want to talk about very specifically what some of these underlying Web3 technologies are. And again, these are these low-level technologies on this stack that enable this higher-level emergent behavior. So you can get peer-to-peer applications at that highest level that are decentralized. Again, things like a decentralized Twitter or a decentralized Uber. So in the center here, you see something that you might be familiar with, which is Ethereum. Again, the second largest cryptocurrency by market capitalization. So Ethereum, the major innovation of Ethereum over Bitcoin is adding what is, you remember that scripting language I showed with Bitcoin? It's very limited in those only 2 operational codes that it really executes to run that peer-to-peer cash network. In Ethereum, you have what's called a Turing-complete scripting language. What this means is that the scripting language in Ethereum, again, the scripting language being that programming language that developers can use to interact with the protocol, it's capable of running arbitrarily complex code. What this means is instead of being limited to this idea of sending money from point A to point B, you can build arbitrarily complex financial operations. So thinking about the types of things you can build there, a very basic example that's emerging really rapidly are more advanced financial instruments. So for example, consider a peer-to-peer loan that's enforced by a piece of code rather than an ink and paper legal agreement. These types of more complicated agreements or contracts are called smart contracts because the contracts are executed with code rather than ink and paper. And so when you're thinking about how these blockchains are programmable, this is one of the key defining characteristics of this next generation of blockchain technologies that have really improved on what Bitcoin is capable of. It's this ability to write smart contracts, which are, again, these more advanced operations that are executed in that secure blockchain environment that's verified by these thousands of industrial-scale miners all around the world. So what can you build really pragmatically today with something like Ethereum? For example, this peer-to-peer loan system. This is a real system called Dharma. What this allows you to do is actually collateralize some amount of cryptographic assets, so some amount of cryptocurrencies, in a provable way. So you can actually provably sign that you've kind of collateralized these assets in a smart contract. And then against that collateral, you can actually request a loan of new assets from a counterparty. Again, this counterparty is anyone in the world on the internet, right? You don't need to know who they are or anything like that. And because this collateral is verifiable, if you default on the loan, the collateral can programmatically, at the term of that loan, be sent to the person who gave you that loan. So you can actually have trustless global peer-to-peer loans over the internet. These are the types of more advanced behaviors that you can build using the Ethereum scripting language that you cannot build using something like Bitcoin. So this is, though, just the very, very tip of the iceberg. When you're thinking about what is possible with these more programmatic blockchains, the idea, the limit to what you can build here, it doesn't really exist. Again, because software is just an expression of human thought, really anything we could come up with, any sort of financial instrument, could be codified and executed in this secure environment. These other 2 technologies, the one on the left is called Tasos. The one on the right is called Definity. Some of the major innovations there include alterations to, again, that virtual machine that can make it a little bit more efficient for developers to actually write these smart contracts. So it's just a little bit more accessible for developers all around the world. The other thing is that these systems have what is called on-blockchain governance. And this is where you can actually use your native cryptocurrency units of these blockchains in order to vote on how to alter the protocol of those blockchains. So for example, in Bitcoin, if you want to amend or upgrade or change the protocol, there's no formally verifiable system for how to make those decisions. In these blockchains, you actually have a voting system for how to upgrade and change the blockchain itself. Whoops, okay. So thinking about, what can be built with these kind of programmable smart contracts, one of the major things that people have started to build on top of Ethereum is other assets, okay? So using the underlying Ethereum blockchain, you can actually build your own scarce digital assets that bootstrap on top of that massive Ethereum mining power without having to actually create your own network of miners, right? So instead of having to launch your own blockchain that's verified by a new massive set of global miners, you can actually just bootstrap on top of the Ethereum consensus system, which is verified by these miners, in order to create your own scarce digital assets. Okay, so this scripting language, again, that's very flexible and programmatic in Ethereum, allows you to create kind of sub-assets on top of the Ethereum blockchain. And to date, last time I checked, there has been 63,000 different assets generated on top of the Ethereum blockchain. Some of these can be fungible assets like currencies. Others can be non-fungible assets. So for example, you could have a sword in a video game represented by a token on the Ethereum blockchain. And then that sword could be transferable in a global marketplace outside of one owned by the game makers, right? So you could actually have a sword, for example, in one video game actually be useful as a sword in another video game, right? You have this kind of transferability between various applications that are built on this Ethereum blockchain because that underlying data set is all open source and accessible. Again, what this means is this kind of infinite remixability or iterability by any developer in the world who can interact with these Ethereum-compatible assets. So when you think about all these kind of various Ethereum tokens, you can use those to add a monetary incentive system to more narrow applications rather than this kind of general-purpose programmable blockchain like Ethereum. So to give you one example, previously I mentioned this idea of a peer-to-peer server system that would be necessary in order to build decentralized applications like a decentralized Twitter or Airbnb. There's a system called Filecoin. Filecoin actually so it's a native cryptocurrency unit that allows you to actually sell your file storage available on your laptop or server rack or anything like that in exchange for Filecoins. Other people can then store their files in an encrypted manner, so it's very private, on your server rack or your computer. So this adds like a whole marketplace for file storage that didn't previously exist and wasn't previously possible in this fully programmatic and peer-to-peer manner. There's another project called Golem that's a peer-to-peer computation layer. So for example, instead of shutting down your computer at night, you could actually rent out your CPU and GPU cycles to some, again, totally anonymous developer from around the world who's trying to render some animation or train a machine learning algorithm or something like that. So by adding kind of these very narrow digital assets that are generated on top of the Ethereum blockchain, you can add incentive systems to more narrow applications. So things like peer-to-peer file storage, peer-to-peer computation. And you need that whole suite, again, these kind of prerequisites or dependencies in this kind of peer-to-peer stack of technologies in order to get to this fully decentralized Web3 vision, where there's actually fully decentralized and peer-to-peer applications. So I kind of want to back up. I know this has been a lot, and I want you to think about what does this all mean really? And so I think that it can be summed up relatively nicely in the idea that protocols can just replace companies. So you see the companies up here. There are these central Web 2 platforms, some of the most successful companies of the last 10 or 15 years that have made revenues by actually building a massive network of users where much of the value comes from the other users on that network, and then extracting rent or extracting value from that massive user base. But if you could just snip out that centralized platform that actually owns the network and allow those users to interact very directly in a peer-to-peer manner, it just returns all of that wealth generation back to the users of the internet and back to the user base, rather than to be extracted by Facebook shareholders or Uber shareholders or any of these other platforms. So I really want to underscore again, and I hope this is clear to you now since the beginning of this talk, that this technology is not simply currency. This is not simply a way to pay somebody on the internet. While that is a subset of what is possible here, there's much, much more going on. And the ability to actually decentralize many, many more components of the internet technology stack than just narrowly payments or currency, I think has massive, massive implications. The thing about this trend is that when you as a business see competition from a peer-to-peer decentralized protocol, it's very, very hard to compete because there is no cost structure on the other side. It's just a peer-to-peer network. What you see is a very similar type of dynamic that happened after the creation of file sharing. The peer-to-peer torrent protocol steamrolled whole industries. Now, in a post-file sharing world, there were successful business models that worked. So things like Spotify or the iTunes Store emerged successfully in a post-file sharing world. But that said, it totally upended huge swaths of industry. And we're dealing here not with just a change in interface. Many of these large tech companies, when this transition from desktop to mobile occurred, they could seamlessly transition their power from a kind of desktop computer onto a mobile phone. What we're seeing when you're talking about their business model being upended, they cannot seamlessly transition in that same manner. So this is a much, much larger disruption to these massive web companies than, say, the transition to mobile phones was. I really do view this as the largest megatrend technologically of our lifetimes. I think that we will all look back at the creation of Bitcoin and cryptocurrency as the single most defining technology on the internet ever created. And so I do want to just underscore how big this is and how quickly this is growing. In less than 10 years that this has been around, the growth has been just absolutely phenomenal. And to me, this is the single most exciting investment opportunity that I will ever see in my entire life. So anyway, thank you all very much. I think we have 25 minutes for Q&A, which is great. So I hope you have many, many questions. Thank you. Uh-oh, did I scare everyone away?
I was going to say, can we see some hands?
I know people have questions. You don't have to be embarrassed.
Thank you very much, Olaf. I was thinking as I see all these logos and discussions of things that will replace Facebook and everything, in my experience so far, the user interface experience is really lousy. Like, it's hard to figure out how to use a wallet. It's hard to figure out how any of these services are going to replace it. Like, when do you think we're going to see that transition to friendly user interfaces as simple as I can buy a book on Amazon right now,
Yeah, so I do think it is sort of like using the internet in 1991 or 1992. It's not a good experience for the user, and it's catered very specifically to software developers and technical users. So to me, the reason these don't have good interfaces is because we're not really at that application layer yet. Most of what people are building are these infrastructural components, like, say, a Filecoin or these underlying programmatic blockchains like Tasos or Divinity, before we can start to build interfaces that can really attract common users. So I think a big part of it is that it's too early, so there's not a lot of emphasis on that. because earnestly speaking, end users shouldn't have to really use Filecoin. They should be able to just tweet, and you don't have to actually understand how the internet works, right? In 1992, when you were interacting with the internet, you sort of did have to understand broadly how this worked in order to utilize it. So to me, this transition will come, but it probably is 2 or 3 years away where we start to see some of those early user interfaces. I think today, probably the most friendly use case of this technology is games, and this idea of scarce in-game items. So I was talking about this sword that's verifiable on the Ethereum blockchain as a kind of cryptographic token. It sounds very silly, but I think that is some of the early use case we're seeing. There was a massive swath of users of the Kickstarter website that would back independent video games. And what you're seeing now is those same indie developers that have a massive kind of grassroots following pre-selling these non-fungible tokens that represent future in-game items in order to fund the software development of their game. So you're seeing some kind of interesting dynamics there, but I think it's very early. And I fully agree that the user interface today is not the emphasis. We'll
Me
do
first.
next. Okay.
Olaf, thank you for your enthusiasm. This is great. And cards on the table, I'm a huge fan of the concept of decentralization, and it's great. But you got very enthusiastic about the trillion-dollar protocols and the biggest opportunity in your lifetime. So you weren't around when the internet was started?
Well, I was just very, very young.
I'm kidding. But the value of Facebook is in its centralization. So, we all have Professor Berners-Lee to thank for the, for the openness of the internet and the HTTP protocol. But I can assure you he didn't get rich off of that protocol. So I've lost something in the leap. I'm all for the decentralization, but I've lost something in the leap of your enthusiasm for this being the investment opportunity of our lifetimes, or yours maybe.
Mm-hmm. Absolutely. So this is the big difference with this suite of protocols is for the first time you can have a sharing of truly scarce resources. So every protocol created at the dawn of the internet didn't have this concept of digital scarcity. There was really no way to transfer a file from one party to another party and provably delete it, kind of, on the sender's end. So you had this problem where doing something like, say, provable file storage wasn't really possible because there was no embedded mechanism for digital scarcity, which meant there was no embedded mechanism for payments. And so by adding financial incentives, which is effectively what these kind of underlying cryptographic tokens are, you can enable just a huge swath of new behaviors that weren't possible with those original internet protocols. Now, in order for these kind of decentralized applications to work, there is a very tight feedback loop between users who want to actually interact with these decentralized applications and the underlying holders or speculators in those cryptographic tokens. Because the kind of suite of all various decentralized applications on top of this stack drives demand for that native cryptocurrency token, which is required to actually interact with these systems. And that demand, which drives the price of these underlying cryptographic assets, actually increases the incentives for these miners around the world to secure the network and actually makes the network more secure. So there's a very symbiotic relationship between people actually purchasing and speculating on these underlying cryptographic assets and the users that are actually interacting with the applications on top of that stack of technologies. So to me, we're really talking about like an internet-based store of value, right? That people can actually put their money in and it's sort of defensible because it has this massive suite of applications that are built on top of it that creates a sort of baseline for the baseline demand for those cryptographic tokens, which are required to actually interact with this stack of technologies. So to me, again, it's important to emphasize, though, that today we're pretty far from true supply and demand dynamics governing the price of these assets. Today, it's very much speculative relative to the actual size of the user base. So I think, I hope that's an okay answer. I think you're right, and this was maybe implicit in your question, that today this is not driven strictly by supply and demand economics.
All right. Olaf, if you graduated in 2011, you were probably about 28 years old, right? Approximately, born in '89. And many investment professionals look for gray hair and, 10-year track record and all that stuff. But it seems like being 28 years old is an advantage in this field. What do you think?
So our research team, we have as young as a 20-year-old on our research team. Now, he was mining Bitcoin when he was 14 and studied cryptography and distributed systems at Stanford. So to me, the short answer is yes. I think that there is a major advantage to what is often referred to as crypto native. So for me, the first investment that I ever made in my life was Bitcoin. I had never purchased a stock or made like an angel investment or anything like that before I bought Bitcoin. So to me, coming at it with that native mindset, I do think is critical, especially as investors. And what we do is mostly kind of buy and hold venture style investing in these underlying protocols. It's critical to be able to, I think a decent metaphor for me is like look out the windshield rather than look in the rearview mirror, right? For not just what this technology could improve upon incrementally that already exists. So like say, make remittances more efficient, which I do think this technology has the potential to do. But that's sort of an incremental improvement on something that already exists. I think when you're coming at it with a bit of a more crypto-native mindset, you can think about what types of applications have we never really imagined that this technology could enable. So when you're looking kind of out that windshield, you have to have a lot of imagination. Because the thing that was so powerful about the internet is not that it ported, say, the libraries of the world onto the internet, but rather that it enabled what I would call these internet native applications. So things like Facebook, there was not an analog version in the offline realm. It was natively enabled by this technology. And so when we're thinking about what will be the blockchain native apps that are enabled by this technology, I think it's very, very important to come at that with this kind of crypto native mindset.
What's the disadvantage of running this?
This is my first fund, is Polychain. So I think that the disadvantage is that I need to recruit a lot of people with kind of decades of fund experience to surround myself with, which luckily I have been able to do.
Hi, Olaf. You're talking about disintermediation across many industries as a result of this Internet 3.0. And one of the obvious targets, I guess you could say, for this type of future application of blockchain is disintermediation in financial markets. Now, you have some pretty powerful incumbents, and these are highly centralized. For example, think of futures exchanges. Obviously, you've got a heavy regulatory apparatus around all of this, too. So how do you think the incumbent participants, as well as the regulators, are going to react to this type of movement?
Yeah, so I'll kind of compartmentalize that into the two categories, the incumbents and the regulators. So the incumbents here, I actually think there's, in a sense, very little they can do. Like I said, I do think there are business models that will continue to work in a sort of post-blockchain world. But in the kind of narrow sense many of these businesses that have made money being that middleman are going to just struggle. The reason being that you can't exactly, as an incumbent that sees this future coming, go build a blockchain. It doesn't work like that. It's sort of like if you were going to be disrupted by the internet, you can't just go build an internet. It sounds kind of almost silly to say that, right? It's kind of missing the point if you think you can own the whole system and extract value from the system. These fully peer-to-peer decentralized blockchain networks are totally incompatible with the centralized revenue extraction business model we've seen from those types of entities. So to me, I do think that the incumbents will have to adapt their kind of core business model. I do think that there's a way they can survive, but it's not by trying to own a blockchain, nor is it just by passively doing what they're doing today. And the second part of your question is the regulatory response. So I think it's very important just first to frame this. This is an extremely global movement, right? This technology is not in any capacity limited or focused on any single geographic location worldwide. So we're talking about a global regulatory question where every single jurisdiction obviously has very different needs, very different regulatory agencies. Very narrowly in the United States, I think there's a few regulatory agencies that are relevant here. The CFTC has said that crypto commodities like Bitcoin are kind of fall under their purview. The SEC has stated that certain kinds of launches of cryptocurrencies, which are often done through what are called token kind of offerings, could represent securities offerings, and those underlying tokens could actually be classified as securities in certain instances. So I do think that there is a kind of approach here being taken that really there hasn't been in the past towards defining and categorizing what these assets really are and how they should be regulated. That said, so far, I do think there's been a very pragmatic and forward-looking approach, not a kind of draconian one. Because I do think that, given how large this technology space is, to me, taking a very draconian approach to this would be sort of like banning the internet in 1993. It's the sort of thing that you would look back on as a very bad decision. Now, that's not to say that appropriate regulation isn't absolutely called for, which in this area, like many new areas, it totally is. So I think in general, in the United States, regulators are taking a very thoughtful, pragmatic approach to this. Again, though, it's very, very multi-jurisdictional, and this is on a global scale. So it's harder to comment on kind of globally how this would shake out from a regulatory perspective. Hey. Oh, here.
How do you see centralized systems surviving? As you were saying, you see there's a way that they can, yeah.
Yeah, so I think a lot of it is, this sounds far-fetched because this idea of centralized revenue extraction feels so core to every business that we see today. But what you're seeing is value creation in these cryptocurrency systems in ways that are outside of kind of like per-use revenue extraction. So and I know this sounds like almost sci-fi, but it's rethinking this concept of revenue and extraction from use of the network. I know that's a little bit abstract, but that is kind of the world that many of these centralized incumbents are going to face. So they're just going to have to figure out how to alter their business and in order to adapt. And to me, it's very industry specific as well. Like each industry might have a different solution.
Since you were saying you have ideas of how they can survive, are there any specific industries that you can extrapolate?
Yeah, so I think, for example, many of these financial service companies that are centralized, there's massive need for many of those traditional financial services in the cryptocurrency space. So things like custodianship or insurance or market making. Like there's a lot of things that traditional financial players can make money doing that they can do also in the cryptocurrency space. I'd say that's what comes to mind, obviously. I do think, though, there are certain kind of narrow categories, though, that it's harder for me to think about how they could survive.
Hi, Olaf. So as you look towards this future that you're painting for us, from a technical or technological, I guess, perspective, what are the things that you worry most about? Whether it be throughput, or us achieving consensus mechanisms that really end up working, because all of this obviously is experimental. Are there other issues that you're worried about? Like, what are you keeping your eye on?
Yeah, so I think that one thing I didn't get into that I'm glad you brought up is a lot of the technical bottlenecks to getting to these, like, peer-to-peer application layer. So scalability is a massive one. Because when you do a transaction or computation or smart contract in this secure blockchain environment, you're requiring thousands of disparate nodes all around the world to execute that computation. It doesn't scale very well. So sort of by definition, a blockchain system is less scalable than a centralized database, which is basically just requiring one computer to do all those computations instead of a whole decentralized set. So for me, one of the big things that we spend a lot of time looking at are really different approaches to improving the scalability of these systems. So it gets pretty technical thinking about what a lot of these trade-offs are, but the trade-offs often come down to basically that kind of anti-fragility that I mentioned of a decentralized and highly secure system relative to just transactional throughput and scalability. So it's how can we achieve highly secure and decentralized anti-fragile system which could never be destroyed by any centralized actor who wanted to destroy the system, versus achieving that kind of throughput that is required to store every tweet, right? Which is substantially higher than what, say, Bitcoin and Ethereum can support today.
Olaf, thanks for your presentation. Based on that and tying together some other questions, and I think I can guess at what your answer is to this, but how do you think about these enterprise blockchains, the private blockchains, which offer potentially security and higher throughput? So,
in general, I think the concept of a private blockchain is a bit of an oxymoron. It's not, so I think a decent metaphor is thinking about the internet. It's not to say that there's no use for an intranet, right, where so for example, the military uses a large intranet that doesn't have kind of external access. And that can be useful for a kind of subset of applications. I think my main perspective is that if anyone who believes that concept of a private blockchain is really the critical innovation here is really missing the picture. It's kind of a very small subset of things that could be improved, and I think it's kind of, again, it would be missing the larger picture, which is that these totally open blockchain systems just will much more substantially affect the world than this concept of a kind of private system. And I really, even using the word blockchain in a private context, I mean, you lose all of these kind of security guarantees that make this so valuable. So that, the fact that these smart contracts work is because you have this distributed network all around the world verifying these transactions. If I was just verifying the Ethereum network only on my computer, you would lose all the good properties of the system. So to me, it's not that there's no use there, but it's much, much smaller than these open systems.
Hey, curious, you mentioned Golem and Filecoin as examples of kind of applications that can be useful maybe in the next year or two, but I'm curious, like, it seems like if you're a fund manager, you use Amazon Web Services, those would be if you're just worried about kind of cutting costs or cost structure, like those could be interesting replacements, and then the benefits of like not having a centralized point of failure. I'm curious for like, how far away are people from being able to use those types of services? And then in addition to that, like, are there others that you would think that could be useful from an application side for this type of audience?
So I think a lot of the really exciting things that I've been tracking for a while are launching in about the next year. So Tasos, Dfinity, and Filecoin, three of the technologies I mentioned, will likely all go live in the next year. Golem is live today, the peer-to-peer computation layer, so you can actually go sell CPU, GPU cycles on that today. It's not to say, to your point, that it's easy, right? This is like a tool for developers. So I really do want to emphasize that the kind of end user-facing applications that drive value to the end users, I really think these are at least a year or two away. We're just early, and I think scalability is a major question. I think even just the design or architecture of these underlying programmatic blockchains is a big question. So I brought up very briefly, and this gets a bit technical, but thinking about the design of the virtual machine. So the virtual machine here being the kind of component of the Ethereum blockchain that actually executes smart contracts. You have to write smart contracts in Ethereum in a custom language called Solidity. So if you're a developer, if you want to debug your smart contract or you want to reference a library, it all has to be kind of rebuilt in this custom language called Solidity, which is kind of a big bottleneck, actually, because you're looking at this language that's, call it 3 years old to power this kind of global smart contract infrastructure. It's somewhat not ideal. So what people are working on now, and this is, for example, in the Dfinity system, something people are working on, is using something called WASM, or WebAssembly, at that virtual machine layer. At a very high level, what this allows you to do is write smart contracts in any programming language. So you could write a smart contract in C or JavaScript or Rails or just kind of any programming language. So then all of a sudden the set of development tools, so like debuggers and libraries and everything, expands dramatically from what exists with Ethereum Solidity. And just like the global set of developers that can interact with that obviously grows exponentially as well. So there's there's a lot of improvements that's a super low level improvement that I actually think could have rippling effects and accelerate the path to that user-facing application layer, but it really is at least 1 or 2 years away, I think. And I think that's all the time we have for questions. So thank you all very much.
Real quick?
Okay, yeah, one more. We can take one more.
What's your opinion on the effect of token velocity on the value of a utility token?
Yeah, so kind of how quickly a token is transacted in a system. So to me, in general, a token that is only used very narrowly for a payment mechanism, likely won't drive a kind of store of value case for the end users. So people won't actually want to necessarily hold on to these underlying tokens. So in general, I'd favor a kind of mechanism that required some sort of like staking, for example, which is this concept of effectively taking a token and then kind of bonding it in order to prove your honesty. So like in the Filecoin system, people who are actually offering to store files have to actually stake or bond their Filecoins. And if they act dishonestly, like for example, they say, I've stored your file, but then when you go back for retrieval, they don't have it. They'll actually, the technical term is they'll get slashed and effectively lose that stake or bond that they put up. So I would favor systems like that when thinking about which of these actual cryptographic tokens will derive value over a longer time period. Okay, thank you, everyone.